Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video introduces the F distribution and demonstrates how it applies to performing hypothesis testing and constructing confidence interval estimates for two population standard deviations, or variances, using both the old school approach and StatCrunch. Let's get started. So, as I just mentioned, we're going to be using a new distribution to perform a hypothesis test and construct confidence interval estimates, and it's based on what's called the F distribution. The F test, which is based on the F distribution, is very sensitive to departures from normality. So, we've got a pretty strict requirement that our samples have to be normally distributed. But aside from that, this runs pretty much like we've seen before. To start with, let's learn a little bit more about the F distribution. So our method for testing claims about one population standard deviation or variance used the chi-square distribution. Well, when we move on to two population standard deviations or variances, we're going to use a different distribution that's like the chi-square distribution, but has one main difference, which is that the F distribution has 2 degrees of freedom as opposed to just one degree of freedom variable. So because of this extra degree of freedom variable, the F distribution is skewed even more than the chi-square distribution is. Okay, the density curve will never fall below the horizontal axis. Values are always positive, so it has that in common with the chi-square distribution. But as I just mentioned, the F distribution uses 2 degrees of freedom values. So there's df1 and there's df2. And each of these degrees of freedom come from the different samples that you're taking to represent your two populations. So df1 is going to be the degrees of freedom in the first sample. df2 will be degrees of freedom in the second sample. So our F test, we're going to assume that the following requirements are met. So there are assumptions that are built into the test itself. And the first one is that the populations that we're testing are independent. So there's no dependency, there's no matched pairs, there's no connection between individual data points from the different groups. The populations are independent. Second, the samples are going to be simple random samples. Third, both the populations are normally distributed. That's a pretty strict requirement there. We also use some special notation when testing two standard deviations or variances. So as we've seen before, subscript 1 is going to denote one sample, subscript 2 is going to denote second sample. But whereas before we were looking at this and saying, okay, whichever sample is listed first is going to be sample 1, here sample 1 is going to be the one with the larger variance. So it may not necessarily be the one that's mentioned or listed first. It's the one with the larger variance. There's a reason for that we'll get into shortly. The sample sizes for the different groups, okay, are going to follow that same convention. So N1 is not going to be the sample size for whichever group is mentioned first. It's the sample size for the sample with the larger variance. And so N2 is going to be the sample size for the sample with the lower or lesser variance. Okay, and you're going to see that same pattern falling for all of your other variables. So mean, standard deviation, the whole bit. We test our claim by using an F-score. And the F-score is, this is the F distribution is what gives us, the name of the test is the F test. So of course we're going to represent this with the letter F. And notice that the F-score is simply the quotient of the first sample variance over the second sample variance. Keep in mind that the convention we have, that the first sample variance is the larger of the two. So the first sample has, we put that in the numerator, has degrees of freedom df1, and the denominator has degrees of freedom df2. Okay. Again, the first sample is the one with the larger variance. So we're putting the larger variance on top of our fraction, and then the lower variance goes below. So that gives the F-score some unique properties, okay? First of all, because variances are never negative, okay, you're always taking that standard deviation, which could be positive or negative, but when you square it, the variance then is always positive. So you're taking a positive number, dividing it by a positive number, you're going to get a positive number. So the F-scores are never negative, they're always positive. And because of the convention of the way that we assigned which one is sample 1, which one is sample 2, we're always putting that larger variance on top. So you've got a larger number divided by a lesser number. So the number that comes out of that division is always going to be greater than 1. It's never going to be less than 1. So if you get an F-score that's less than 1, you know you did something wrong. And usually the thing you did wrong was you flip-flopped your samples. So you just got to turn your samples around, and that'll give you the right F-score. The closer your test statistic is to 1, the more evidence you have that the variances are equal. That should make sense. If the variances are the same, then you're taking one number and dividing it by the same number, and that's just going to give you 1 every time. So the closer those two variances are to being equal to each other, the closer that test statistic is going to get to 1. And then, of course, you know, to get the p-value and the critical value, you either got to get an F distribution table, which is using the old school approach, or you're going to use software like StatCrunch to calculate it for you. Confidence intervals can work the same way. Okay, we can test claims regarding 2 standard deviations or variances, and we'll show you how to do that here in a minute. But the way we construct it with the old school method is with this general expression here. So it always looks like a beast, and it is a beast, but this is why I use StatCrunch, because it's a lot simpler than going through this mess. But if you want to, take the scenic route, as it were, then hey, more power to you. So for most of your assignment problems, you're going to want to use StatCrunch. When you're asked to do hypothesis testing, okay, just go to variant stats, to sample with summary. Okay, typically you're not going to have data, but if in the case that you do have actual data, go ahead and select with data. And then make sure you put your values there in your options window, keeping in mind that typically your problems will give you standard deviation, but again, this Fields and StatCrunch is looking for variance. So you want to make sure you put the variance in. You got to square those standard deviations. You also want to make sure that the larger number goes in the first sample. Okay? If you don't get that right, then you're going to get the wrong F-score. Your F-score will end up being less than 1, and it's going to give you the wrong answer. The F-score is always greater than 1, so make sure you put that larger variance in the first sample. Typically, you're going to leave that 1 value alone because you're dealing with a ratio. So you're just going to leave that alone, and then just make sure that that inequality sign drop down matches your alternative hypothesis. Okay? And then away you go. Press compute, read your test statistic and p-value right off your results window. You don't have to adjust them any, take the square root or anything like that. Just take them straight off the window. Confidence intervals, again, work the same way. Okay? Same menu options. You're just going to flip that radio button down to confidence interval, and we've got the same rule with the 1 minus 2 alpha for the confidence level. So unless you have a mismatch between the alternative hypothesis and your claim, you're going to want to use 1 minus 2 alpha to calculate your confidence level. And then just go ahead and hit compute, get your results window, upper and lower limits right there from the results window, the same as we've always seen them. And that brings us to the end of this mini lecture. I hope you found it helpful. You could find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.